Hi, this is Doc Revis with Watch Me Work It. Combustion analysis calculations of an unknown containing C, H, and O. Watch me work it. Here's the problem. What is the empirical formula of a compound composed of C, H, and O if the combustion of a 0.255 gram sample gave 0.561 gram of carbon dioxide and 0.306 gram of water? Since we're saying empirical formula, we need to get to moles. That's always the goal of empirical formula. Do we have moles? No, we have grams. Do we have grams of carbon? No, but we have grams of CO2. Do we have grams of hydrogen? No, but we have grams of water. Do we have grams of oxygen? No, but we have an indirect source of getting to oxygen. So let's get going with this problem. Let's start with what we do have. We have carbon, and we have an indirect source of carbon, and that's going to be 0.561 gram CO2, because that's an indirect source of carbon, and this will go to gram CO2 on the bottom, and this will be mole CO2 on the top. And since I'm looking for mole carbon, I have to keep going. So this is going to be mole CO2 on the bottom, and this will be mole carbon on the top, and therefore we'll have our moles. We can do likewise with hydrogen. We have hydrogen, and we have an indirect source of hydrogen in 0.306 grams of H2O. We're going to convert that to moles of H2O. We do that because if we're going to interconvert, moles will do the interconversion of moles H2O to moles of hydrogen. Let's go back now and put all these values in and run some numbers. We have grams of CO2. That's going to be 44.0. That's the molar mass by calculating 1 carbon and 2 oxygens to every 1 mole. And mole C to mole carbon dioxide. For every 1 mole of carbon dioxide, we have 1 carbon in it. We can see it, 1 carbon in CO2. And if we punch this number through, we will get 0.01275 mole of C. Let's do likewise with hydrogen. We have the gram per mole of water is 18 to 1 by calculating 2 times hydrogen plus 1 oxygen using values from the periodic table. Here we have 1 mole of hydrogen, we have 1 mole of water. And in that 1 mole of water, we have 2 moles of hydrogen. So here we have this value. If we punch through in the calculator, mole of H. To find the moles of oxygen, we will need to do a bit more math. We know that this is the total mass of the sample. And we know then that that mass minus the mass of carbon and hydrogen will give us the mass of oxygen. So let's find the mass of carbon and hydrogen so that we can determine the mass of oxygen. So to determine the mass of carbon, we would take the moles of carbon. This is going to be carbon again here. Take the moles of carbon times bar moles carbon to grams of carbon. And this is 12.0 grams for every 1 mole of carbon. And this is going to give us the grams of carbon, which equals 0.153 grams of carbon. Next, let's get the grams of hydrogen. So this is hydrogen. So we take the moles of hydrogen that we've already calculated, and we're going to convert these to grams of hydrogen through a dimensional analysis. Mole to gram of H, and gram is 1.00 to every 1 mole. And this will be 0.034 gram of hydrogen. So if we add these grams together, we get 0.187 grams that we know about based on analysis. And therefore, we can do subtraction math to get to the grams of oxygen, we would take the original mass of 0.255 minus 0.187. This is the sample, and this is the known C plus H. And we subtract these two values, and we get 0.068 grams of oxygen. So now that we know the grams of oxygen, we can convert the grams of oxygen to moles. So we would take the moles of, we find the moles of oxygen by taking the grams. So this would be 0.068 grams times bar, gram, O, to mole, O, and grams, 16.00 to every one. And now we have the moles of oxygen at 0.00425 mole of oxygen. Now that I have everything that I was looking for, I can divide by the smallest. So this is 0.00425, the smallest number of moles from the calculations. Because to do empirical formula, we need moles, and we need the ratio of those moles. So I'll put these numbers in, then I'll punch them through my calculator. If I punch carbon through, I get 3. So that's going to be 3 carbon. For hydrogen, I get 8 hydrogens. And for oxygen, it's 1 O. So my empirical formula is C3H8O. So there you have it, combustion analysis calculation of C, H, and O. When one of the species is missing, you'll take the sample minus the ones that you can account for by indirect calculations. All right, there you have it.